Exercise 302 is about adding and subtracting vectors, so we're going to start with addition. So to add vectors geometrically, you just place them tip to tail. So we've got the vector here A, which is 2, 3, and we've got the vector B, -4, 2, and we're being asked to add them. So in order to do that, what I'm going to do is I'm going to duplicate them and drag them over here. So there's vector A, I can put that wherever I want. And then the head is at the top. So I'm going to duplicate vector B and I'm going to drag that over there as well and put it at the head of vector A. So A is going that way and B is going that way. I'm also going to label capital A, B, C on there. So to add them, all I need to actually do geometrically is join from A to C. So the vector AC is the answer there. So AB plus BC is equal to vector AC. Now we can actually see here that the vector AC is -2, 5. So let's just write that up here as the solution. Now we can also add them numerically rather than geometrically. So if we go vector A plus vector B, so that's 2, 3 plus -4, 2, it's just straight addition across. So 2 plus -4 and 3 plus 2. So that gives us -2, 5. So I'd like to talk about also the parallelogram law. So what we see here is that A plus B, if I add these vectors, I do get vector C. Okay, so if I go AB plus AD, that's the same as AB plus BC. And that's because this vector BC is equal to the vector AD. Now AB plus BC, there's this really cool little thing that happens when you get the B's together like that with an addition between. The B's do a magic disappearing trick and you get vector AC. There's another way we could look at it. We could start by saying that AB plus AD. So what I've done here is I've written the AD first. So AB plus AD is the same as AD plus DC. And that's because AB is equal to DC. So I've just picked up AB, I've shifted it up here to add them. And then just like we saw in the previous part, if you put them head to tail like that, the result is there. So the D's did the magic disappearing trick and we got AC. Now I will just draw on that solution. So the vector AC is the answer there. So it's the long diagonal of that parallelogram, which is why it's called the parallelogram law. So let's talk about vector subtraction. So firstly, if I have A minus B, that's the same as doing A plus -B. So we can do it exactly like we did before. We can also talk about this as AB minus AD. So let's see what happens. So firstly, AB minus AD, the negative of AD is the same as adding DA. So that's like saying AB plus DA. Now, if I just turn that round, so it's DA first and then AB, so from D to A and then A to B, that's my addition path from there to there. So now, because the A's are together, they can do the magic disappearing trick, and we do get the vector DB, so from D to B. So when you subtract, we do get from the D to the B if that first letter is the same. Now, let's look at that in reverse. So the vector BD from B to D is the same as BC plus BA. Okay, from B to D is the same as BC plus BA. That's by the parallelogram law. Now BA is the same as negative of AB, and BC is the same, BC there is the same as AD, so AD minus AB, again, see how those letters have kind of switched places. Let's just draw that vector on there. Now I haven't put a direction there because in the first one I was talking about DB, in the second one I was talking about BD, so my direction did switch when I was doing those two examples. What we can clearly see though is it is the shorter diagonal, well, the other diagonal of that parallelogram. So when we added we got AC, when we're subtracting we're getting BD or DB depending on which way we subtract. So let's just look at this numerical example. A is the vector 2, 3 and B is the vector negative 4, 2. What's A minus B? So A minus B is 2, 3 minus negative 4, 2. And we can just do the usual thing. So 2 minus negative 4 and 3 minus 2. So 2 minus negative 4 is 6 and 3 minus 2 is 1. So the answer is 6, 1. Now we can also should note too that if you've got A minus B equals C, just like with normal algebra, you can add the B onto each side and get A equals C plus B.